So we talked about quadratic expressions. That's what we've been doing. We've been factoring. The difference between an expression and an equation is an equation has an equal sign, hence the term equation. Standard form of quadratic equation looks just like the standard form of a quadratic expression, ax squared plus bx plus c, but now we have equals 0. Equals 0. So instead of just having like y equals whatever, and it's just a function, we now have ax squared plus bx plus c equals 0. Where a is not equal to 0, because then that would be a linear. The first way we're going to look at solving these is by factoring, because we have this what's called zero product property. If you multiply two numbers together and you get 0, one of them must be a 0. That's how multiplication works. And so we take that principle and we apply it to solving these quadratic equations. We factor them, and we have two factors that equal 0, which means this factor has to equal 0 or that factor has to equal 0. So we have two possibilities for what x can equal. All right, so the very first rule of solving quadratic equations by factoring is that it has to be equal to 0. If it's not, you have to subtract the number over so that it is equal to 0. All right, so let's look at the first example. So my first rule is it has to be equal to 0. So I'm just going to move that negative 15 over. How do I move it over? Yeah, I'm just going to add 15 to both sides. All right. And so I add 15 to both sides. Now I have 2x squared minus 11x plus 15. Now that I have it equal to 0, I need to factor. Okay, so you can factor this either way of the ways that we did. Remember, we did setting up all of your factors and then seeing which ones you can pair together, or you can do it by the method where you multiply across, okay? And so if you do the method where you multiply across, you're going to multiply 2 and 15, which gives you what? 30. I need factors of 30 that add, because it's a positive 15, to give me 11. Yeah. So I have 5 and 6. 5 and 6 multiply to give me 30 and add to give me 11. Specifically, I need a negative 5 and a negative 6, right? Negative 5 times negative 6 is positive 30. Right, which is what I want. Negative 5 plus negative 6 is negative 11, which is what I want. So I'm going to rewrite this. I'm going to say 2x squared, and I'm going to rewrite this to negative 5x and negative 6x, and then I'm going to leave the last one the same. Now, how do I factor a 4-term polynomial? By what method? Grouping. So I'm going to group this. I grouped behind a negative, so what do I need to do to the 15? Change the sign, right? What can come out of the first group? Just an x. And what am I left with?
2x.
What can come out of the second group? 3. And I'm left with 2x minus 5. That's what I wanted. All right. Now I'm going to factor these, right? I have that whole group in common. So if I take that group out, I'm left with what? X minus 3. And so I have it factored. My rule says then, the first group has to be equal to 0 or the second group has to be equal to 0. And that's exactly what I do. So I say, well, 2x minus 5 has to be equal to 0 or x minus 3 has to be equal to 0. And then I'm going to solve. Add my 5, divide by 2. 5 halves. Add my 3 or x equals 3. And those are my two answers. So for this example, you do not have a middle term, so your b is 0. Okay, you just have an x squared and a c, like you have a number, all right? And so you could do factoring here, and then you end up with sometimes a special case. There's also another way to do this, and the other way to do this is just to get the x squared by itself and take the square root, all right? And so if I have something like this, I can actually add that 180 over. So instead of solving by factoring, I'm going to solve by finding the square root. So I am going to get everything on the other side except my x squared. We're trying to isolate the x squared. So we have 5x squared equals 180. What do I need to do to get the x squared by itself? Right, so I'm going to divide both sides by 5, right? What's 180 divided by 5? 36, all right? And then I have an x squared equals 36, so I can take the square root of both sides. Now remember, when you have a square root with a variable, I have to consider the positive and the negative root. So x could equal 6, or it could equal negative 6 here. So not every quadratic can be solved by factoring or taking the square root. Sometimes you can solve by another method. We're not going to solve by graphing, really because there are other methods that solve easier than graphing, even if you have a graphing calculator. So the graphing calculator, you can put it in and you can kind of walk along and you can find your zeros. But I want to show you one and what it means to have a zero of a function. A zero of a function is the solution to what happens when the function equals 0. It is the x value that makes your function 0, okay? Which means your y is 0. So whatever x you plug in, if the answer is 0, that's your y value, okay? And so if I were to take this one that we did and we got these zeros, it was 2x squared plus 4x, and we move the 6 over equals 0. And so if I were to graph this particular one, I would do just like I've done before. I would say find your axis, find your vertex, find your y-intercept, and then graph it. And so if I did that, I would say, well, my axis, that's going to be, how do I find my axis when it's in this form? Negative b over 2 times a, right? So what's my axis here? Negative 1. And so I'm going to go to my negative 1. And I'm going to do my dashed line. That will tell me what's going on. Is this one going to point up or point down, by the way? It's going to point up, all right? So if this is my axis, how do I find my vertex? Right, so I'm going to take this and plug it back in. 2, negative 1 squared plus 4, negative 1 minus 6, all right? So negative 1 squared is 1 times 2, 4 times negative 1 minus 6. What happens here? Negative 8, so I'm going to come down here to a negative 8 right there. And then what is my y-intercept?
It is your 6.
6 right here, okay? Right. Now I have actually a little more information. I have my zeros. That is where my y value is 0. Where specifically on the coordinate plane is your y value 0?
On the x-axis.
On the x-axis, right? So my x is 0 at my y-intercept. My y is 0 at my x-intercept. So these tell you a couple of things. First, they tell you where the function equals 0. So where does the function equal 0? Okay? They also tell you your x-intercepts. All right? So your x-intercepts are where you cross the x-axis, all right? And so that also tells you where you can plot something on this graph. So at positive 1 on the x-axis, negative 3 on the x-axis, I can plot those points. And you can see that's what would happen if I were to go up. But that is called the 0 of the function. So another name for x-intercept is called a 0. A 0. And that's what you're solving for when you solve these quadratics equal to 0. You're solving for not only where the function equals 0, but you're literally solving for the x-intercepts. And so very often it'll say find the zeros, and it means find the x-intercepts or set the function equal to 0 and solve it by one of these methods.